Good morning. Welcome to the optics course. I hope you have all read the syllabus on Canvas. If you have not yet read the syllabus, I urge you to do so. It is very important to read the syllabus. As mentioned in the syllabus, we will be using Pedrotti and Pedrotti Introduction to Optics, third edition for this course. In the first lecture, before we begin to study optics, I would like to discuss the fundamental and the foundational principles of physics. This is very important to make sure that there are no misconceptions. To begin with, I'd like to tell you a small story about Richard Feynman. So Richard Feynman went to MIT and then to Princeton. He got his doctoral degree in physics and he went back home. And he was talking to his father, and his father, who was always interested in science, asked Feynman a question. He asked Feynman how light is emitted from the atom when an electron goes from a higher excited state to a lower state. Um, Specifically, Feynman's father asked Feynman if there is a photon that is inside the atom that is released when an electron jumps from a higher state to a lower state. Feynman told him that there is no photon inside the atom, and then Feynman's father was confused because if there is no photon inside the atom to begin with, how can it be emitted or released from the atom when an electron makes a jump from a higher excited state to a lower excited state? And Feynman basically apologized to his father and said that he couldn't explain it. And it is the same Feynman who also said that if you understand something, you should be able to explain it in simple terms. So, having said that, if we cannot explain what light is in simple terms, that means we don't understand it. And this has to do mostly with our highly mathematical approach to physics. The modern physics has been so mathematical that the underlying concepts have been swept under the rug. So in the first lecture, I would like to discuss the fundamental principles and define what is physics. So let's start with that question, what is physics? So physics in the broad sense is the rigorous study of the physical world. So, rigorous study of the physical world. So, all that we know begins with the physical things that we know, and we know these physical things directly through the senses. So, we get to know about the physical world through our senses. For example, we can see things, we can hear, we can feel. So through the sense acquired knowledge, we can know the physical world. But the sense acquired knowledge or the sensorial knowledge is very particular type of knowledge. Particular meaning, for example, if I touch a cold glass of water, my skin is in contact with the glass and it undergoes a change, and that's how I feel that the glass of water is actually cold. But this knowledge, this change in the skin, comes from touching that one particular glass of cold water. So, in that sense, the sense knowledge is very particular. But the intellectual knowledge builds on this sense knowledge and draws more universal aspects. For example, if you touch one specific glass of cold water and you experience how that particular glass is cold, you can still draw the general idea of coldness from it. So that is our intellect. So senses give us particular knowledge, and then we have intellect that gives us universal knowledge. So we have to combine these two things, um, and that's what the study of physics is. It's basically the rigorous study of the physical world around us. So Aristotle laid the foundations for physics, although he could not explain a lot of things very well. For example, he could not explain the causes of motion or how planets went around the sun, or many other things. Although he could not successfully explain those things, nevertheless, he did successfully establish um, fundamental principles of physics. The first part of physics that Aristotle established is grounded directly in the sense knowledge that I was talking about, and it can be called the foundational part of physics. So, what we are going to do now is look at these fundamental principles or the foundational principles of physics. So, foundational principles. So, the first foundational principle is that things exist. So, we are studying the physical world. We are looking at physical things that are already existing around us, and we are trying to study them. So, their existence is primary. We can study things only if they exist. If we cannot study something that is not existent, right? So the first principle is that things exist. We are building everything based on this. That we are looking at the physical world. We are observing the physical world. We see that there are things, and we're trying to study these things. So the first thing is that things exist. Physical things exist, right? So before going on to the next foundational principle, right? Let's ask ourselves a question: what is a physical thing? A physical thing is, it is something now, but it can be something. It can become something else. So, for example, if I have a green apple, it is green color apple now, but it could become a red apple, right? So, physical thing is anything that is something now, but can become something else. That is what a physical thing is. So, physical things, they have potency, or things, they can change. So things change, things constantly undergo change, right? So things are something but can become something else, right? um, they are actually something but are potentially something else. That potency is what we are calling as the change. And then comes the most important principle of non-contradiction. This is very important for our course actually, because there are a lot of misconceptions around what light is. People think that light is both particle and wave at the same time in the same way. That is not so, right? So for that, we need to understand and digest what principle of non-contradiction is. So, principle of non-contradiction states that something cannot be and be at the same time in the same way. So, for example, if I take again the example of an apple, we may have a green color apple or a red color apple. We cannot have an apple that is both completely red and completely green at the same time in the same way, right? So if we say that light is both particle and wave at the same time in the same way, that's basically not that doesn't make sense, because something cannot be and be at the same time and in the same way. So the principle of logic is that we either have X or not X. It derives from our principle of non-contradiction, right? It is either raining or not raining. It cannot be both raining and not raining. So that is against the principle of non-contradiction. Another important foundational principle is principle of causality. Principle of causality states that something cannot change itself. Something cannot change itself, right? So something cannot change itself in the sense that something cannot give itself something it doesn't have, right? Um, it can, however, act on other things according to what it is. For example, if I have a green color apple, the green color apple itself cannot cause itself to change and become a red color apple. There is some other agent. There is another agent, a cause that must be there for an effect. So, principle of causality basically tells you that for every effect there is a cause. Without a cause, there cannot be an effect. And the final one is substance and properties. Substance and properties. So, substance is something that can exist by itself. So, substances exist of themselves, while there are certain things that can exist only as a part of the substance. We call these things as properties. So, some things or substances, these are substances, exist of themselves. Right? Um, while properties exist as a part of the substance. So let's consider an example. So if I have an apple, again, I would say an apple is red. So apple is a thing that exists by itself, it's a substance. But the color red exists in the apple. So for example, red or color is a property. It's not a thing, it's not a substance. Because try to think about red by itself. You would end up thinking of red something. You'd be thinking of red paint or red liquid or red wall or red something, but you cannot absolutely think about red by itself or in general any color by itself, right? So these properties have to exist in a substance. A substance can exist by itself, but properties have to exist in a substance. So these are the first five foundational principles that things exist, and we are studying those things that exist, and we are studying how these things change. And to study these things, we know that there is principle of non-contradiction and principle of causality. Every cause must have an effect and vice versa. And then finally, we are making a distinction between what is a substance and what is a property. So a substance is again something that can exist by itself, whereas a property can only exist as a part of the substance. It cannot exist by itself. And Aristotle categorized these properties into nine different categories. So let's look at what these nine different categories are. So following up on the last one, substance and properties, substance and properties, there are nine categories of properties. So the first two types of properties, or first two types of categories, are intrinsic. They are um, quantity and quality. So quantity means extension. Quantity is, for example, if you have a plane, it is extended, right? That is quantity, right? It could be number, for example. So I could say I have two apples or three apples. So I'm counting these numbers. That's quantity. Or you could say we have three dimensions. That's also quantity. Quality, on the other hand, is something like, say, whether something is hot or cold, that's a quality. Or what color is it, right? Or how hard is it, whether it is soft or hard. These are all qualitative properties, not quantitative properties. So hot, cold, color, hardness. These are qualitative. The difference between quantity and quality is in the way they add, or in the way they add up. For example, you can take two quantities, add them to get a bigger quantity. For example, I can take, if I have two apples and I bring three more apples, I would have five apples, right? So I can get a larger quantity by adding two smaller quantities. But that does not apply to qualities, in the sense that if I have 100 mediocre physicists and I add them together, I'm not going to get an Einstein, right? So qualities do not add the same way as quantity. Another example for quality, that you cannot add quality, is, for example, you can get maybe like 1,000 snowballs. You still won't be able to heat a pan of water using 1,000 snowballs, because the quality of temperature doesn't add up. If I put 1,000 snowballs together, the temperature doesn't become, boiling point of water, right? Because that is a quality and not a quantity. It is very important to know this distinction between quantity and quality, and we'll talk about it a little later. In the way we measure things, because the way we have been measuring things, the modern scientific method, uses these pretty much interchangeably, and it is easy to get lost there. So let's look at other extrinsic properties. So these two things, intrinsic properties, are intrinsic to substance. They are within the substance, right? So quantity, it is extended by itself. For example, a plane is extended by itself, or an apple, it has extension, it has volume by itself, right? And quality, it could be red, it could be green. It is intrinsic to that substance. And extrinsic properties are relative to other substances, right? One of the first extrinsic properties is relation, right? So relation meaning equality or similarity. For example, I could say, okay, these two circles are equal in size. So I'm comparing one thing to another, right? So that's why it is an extrinsic property. Then we have action. Action meaning one substance acts on another substance, right? For example, if imagine, you have two balls, and if I roll one ball, it can go touch the second ball and make it move. So the first ball is acting on the second ball. Or even a simpler example is, I could heat a cup of water, right? So that heating is acting on that substance or on water and heating it up. So action is, examples of action are, are heating, moving, etc. Relationship is whether two things are equal, or two things are similar. These are all comparisons between two things. So action means that if I'm able to act on another substance, then the other substance should also be able to receive it, right? So reception is another type of property. You should not get confused here. So here action is not used in the same sense as action and reaction in Newton's third law. Here, action means the simple acting on something, right? You're acting on an object. That's all it means. It's not action reaction pair. So reception means if I'm able to act on something, if I'm heating a cup of water, that water should be able to receive that heat. There should be a way in which this water is able to receive the heat, right? So reception, the property of reception is the ability to be heated, or the ability to move, right? Those are reception. Then there is place. So for example, this is quite straightforward. If you're for example sitting somewhere or standing somewhere in a particular place, right? And that position is obviously in relation to other things around you, right? And then orientation, right? So which way you are oriented, right? That's place and orientation. They are relative to other things. For example, this is tilted, or this is pointing up, or it is pointing down, right? Or it is pointing that way. That is orientation. And then the next category is environment. Environment. For example, there is air around us. That's our environment. If you look at a fish, water is the environment of a fish, right? So that's another property. And then the last one is time. So time is a relative thing. We are basically comparing two different changes. Recall that our second foundational principle, right after things exist, was things change. So because things change, you can compare the way one thing changes to another, and comparing these changes is what time essentially is, right? So by saying time, we are comparing the changes in two things. So everything exists at a given moment. Each such moment is lost and followed by another as change occurs. So change is clearly linked with time. Um, it is in time that the change happens, right? Time is essentially the measure of motion, right? It is one motion measured by another. For example, like relative motion of the sun measuring our age, right? Um, and we can use a watch to measure, say, how fast somebody is running, right? So we are measuring two changes. When I look at a watch and I'm looking at a person running, I'm looking at how long it takes for the hands in my watch to change their position, and I'm comparing that to how long it takes for the runner to change his or her position from beginning of the race to the end of the race, right? So we are comparing changes in two different things. So that's why time is not an intrinsic property. It is rather an extrinsic property. So now that we have established these things, I would like to note that quantity is the primary property, right? So quantity is the most primary property of all the properties, right? So, for example, try to think of let's say red color without thinking about it as an extended thing, right? Um, so we cannot think about any physical thing without it being extended. So quantity is primary to all things that we can feel and experience, right? And all physical substances must have extension, right? Um, so if a substance has no parts outside of each other, i.e., if it has no extension, then it cannot change, and therefore it is not a physical substance. So quantity is very primary, and you should also note that quantity and quality are intrinsic properties. Quantity is limited by shape and thus cannot be understood without quality. Right? Quantity can be conceived without quality, but you cannot understand quality without understanding quantity. Right? Okay, so now that we have established these substances and properties, let's talk a little bit about measurement, right? So what is a measurement? So what is a measurement? Measurements are essentially relations. So, for example, if I say this book weighs 10 kilograms or this book weighs 2 kilograms, then I am comparing the weight of this book to an iridium cylinder, a standard that I'm calling a kilogram, right? So that 1 kilogram doesn't tell you anything about the nature of mass. It only tells you how much this book weighs in comparison to there is the standard cylinder sitting somewhere in some museum in Paris, how much it weighs compared to that. That is all it does, right? So a measurement is essentially a relation. So measurements are relations. And in measuring, we end up quantifying things, right? So we quantify things when we measure, right? So for example, if I say this table is 120 meters long or something, 120 centimeters long, we'll say, right? Then that length of that something, that is quantity, right? And we are quantifying using measurement. So this 1 meter again, there is a standard meter stick somewhere in Paris again, some museum, and we are measuring the length of this table, um, length of this table in comparison to that standard. So so measurement is a relationship. But in quantifying things, we also quantify certain qualities. For example, temperature. I could say, okay, this is at a temperature of 50 degrees, or this is at a temperature of 100 degrees C, right? So there I am measuring the intensity of a quality. So temperature itself is a quality, right? Not temperature itself, whether something is hot or cold, it's a property. And I'm using temperature as a scale, as an intensity of that particular quality, how hot it is or how cold it is. And by using temperature as a scale to represent the intensity of quality, hotness or coldness, I am representing a quality I'm representing a quality in quantity. So I'm representing a quality in terms of quantity. This is very important to understand because we are lost in quantities. For example, if I say what is mass, you may say, oh, the mass is 1 kilogram, or the mass of this object is 10 kilograms. But that is not what mass is. Mass has, that is how you are quantifying mass. That's how you are measuring it, right? So that's just a measurement, which is a relationship, right? Um, so, uh, so similarly, even intensity of light would be a quantity, right? Okay, so now let's talk about no, light a little bit here, and then we'll end the first lecture. So, so what is um, space? Right? So you are often given this wrong idea of space being nothing, that space is emptiness. But think about it, how can nothing exist? So the question is, can nothing exist? When I say nothing, by definition, it is non-existent. So how can something that is non-existent exist, right? So when it is wrong to think of space as nothingness or emptiness. You may have heard these, you may have watched or you may have read these things about general relativity that Einstein came up with. And you may have heard, oh, this is because the space-time is bending or warping and things like that. So if space is nothing, how can it bend? How can nothing bend? Think about it, right? So it is not emptiness or it is not nothingness. So space is essentially quantity. It is pure extension. So space has parts outside of each other. So it is extension. So you have extension, and that extension is what we call as space. And all these electric fields, magnetic fields, they exist in space. So space exists by itself, and this electric field or magnetic field or gravitational field exists in space. So these are properties of space. And space is the substance that exists by itself. It is pure extension. And we often think of things taking up space. Things don't take up space, they create space. Right? Space comes into picture because there are things. Right? So space is, it is not nothingness, it is not emptiness, it is extension. And space has properties and fields like electromagnetic fields or gravitational fields, they exist in space. And space, in fact, the way it changes is what we will look at when we study deeper about fields. And because light is made up of electromagnetic fields and it exists in space, light is a property of space. Right? And this is what we are going to study. So we are going to look at, we're going to use these foundational principles, and we would quite often go back and refer to these foundational principles. I will also upload a short description of these foundational principles from PFR mechanics book. If some of you have not taken the course by Anthony Rizzi. So if you have taken some of you have taken the PFR mechanics course at Clemson, you would already be familiar with these things. But for those of you who have not taken this course, I will upload the material on Canvas, so you can read and understand what the foundational principles are and what a measurement is and what properties are. So with that, we will stop here for lecture one, and I want you to ponder on these questions after the first lecture. I will also upload this as homework one. I want you to answer what is physics. All right. Then what are the foundational principles? Foundational or fundamental principles that we discussed, right? Um, what are the 9 types of properties, right? Provide examples. Don't provide the same examples as the things that we discussed. Come up with your own new examples, right? And I would also like you to tell me what is space and what is light. So the thing about answering the questions is you don't need to have the right answer, but I want you to start thinking. Don't try to answer hoping to get the right answer, 100 points. Um, the knowledge begins with trying to answer, not the right answer. We don't get the right answer in first go. We have to attempt, we have to try and answer things. That's more important. So I would like you to try and answer these things, these 4 questions, which I will again upload on Canvas. So we'll stop here. Um, uh, Ponder over these questions. Read PFR mechanics introductory chapter, and then we will start off with Pedrotti and Pedrotti chapter 1 in the next lecture. Thank you.